Okay, on this question, let's read it first off. You are interested in investigating whether gender and being a math science major are associated at your college. Well, let's just stop right there. The key word here is associated. Gender and being a math science major are associated. Associated. So what kind of test is that? Let's look at the notes real quick. As you look at the notes, oops, there it is on this material, you're going to see that it's a test for independence. How do I know that? Well, associated. If two things are associated or connected or related, that means they depend on each other, right? Like they say your dependents, those are your children, right? Or your spouse or your children are the people in a family, that are the people dependent upon you. Your relatives, your relatives, people you're related to, you're connected to, you're associated with. That's a test for independence. We're seeing if these two things are dependent or independent. So you want to look for those buzzwords: associated, connected, related. Things like that mean test for independence. Are these things connected? Or are they independent? Right? Are they separate? Okay, so that means, getting back to the problem, we're going to choose test for independence here. And what are the null and alternative? Well, let me write that out right here. HO and H1. We go down to the notes and it'll tell us. HO, the row and the column have the same distribution or are independent. And then notice H1 dependent. So HO independent, H1 dependent. Let's go back and do that. So HO, and what are the two things? Gender, right? Gender and being a math science major are in, no, okay, getting scribbly there. Independent. Okay, and then H1 is those two things, gender and I'll just say MS, math science major, are dependent. They're connected. Dependent, associated, connected, right? Your dependents are your relatives. All right, so let's come on down. Where does it say this? So the HO is the independent, right? So there it is. Major and gender are independent. And then H1 is dependent. Dependent. Your major and your gender, right? So are men more likely to be math science? Are women more likely to be math science? Are men less likely to be math science? Whatever. That's what we're trying to figure out. Does it make a difference? Does one gender versus another tend to connect more with being a math science major or not? Are those two things connected? That's what are they associated, right? That's what we're trying to figure out in here. A lot of people actually are interested in a lot of colleges as they recruit students. They want to know, are we getting more women? I think they're getting more women now that are into math and science and less men. They're trying to promote men and things like that. So they're always looking at stats about, is the gender, being a man or woman, is that connected with being a math science major, or is it just totally independent? Does it really have nothing to do with it? Does being a man not or woman not make you any more or less likely to be a math science major? Or is there an association? Is there a connection? That's what we're trying to research. Okay, so coming on down. So then they're going to start asking us for the stuff from our calculator. So let's go and see what we do on the calculator. So, yeah, here's some good words. Independent means they do not affect each other. Dependent means they do affect each other, right? Okay, so how do we do the test? That's what we really care about, don't we? We've got to go to second matrix to get to the matrix menu, move over to the edit, select the size. So all this talk means we need to have some kind of a matrix, don't we? We've got to have a matrix here. So how are we gonna get the matrix? What matrix? Well, let's go back and look at the numbers. See what it says here. 200 men, 19% are math science majors. 600 women, 17% are math science majors. Okay. So basically what we're going to need is we're going to need men and women on one side and math science or not math science. This is what we're looking at. We're going to fill in those blanks. Right? We're talking about whether men are math science majors or not, right? This is men math science. This is not math science. This is women math science. This is women not math science. So how do we figure it out? Well, it says a survey of 200 men, 19%. So that means 19% of the 200 men are MS, math science, aren't they? You tracking with me? In fact, maybe I should, let me move that out of the way. Let me move it down a little bit. It's right here. So 19% of the 200 men are math science, MS. So what does that mean? That means, well, here, let me write down below. 0.19 of is always times 200. Hit the buttons on your calculator. I think you get 38. Whoop, that too quickly, looks like. On my pencil, let me double check that. 0.19 times 200. Yeah, 38. So that means 38 men are math science. So I'm going to put that right here. Okay. 38 men, right? So that's men that are math science. So how many men are not math science? Well, the rest of the men. So that would be what? So 200 minus 38, right? The rest of the men leaves 162. So 162 men, this is men that are not math science for the 200 total, right? See how I'm coming up with that? And now let me go to the women. So for the women, do them in a different color here. For the women, what does it say about the women? 600 women surveyed, 17% are math science majors. So 17% of 600 women are math science. That's 0.17 of is times 600. Hit the buttons on your calculator. I'm going to do that right now. 0.17 times 600. I'm getting 102 women are math science. How many are not? Well, 600, the rest of the women are not. 600 take away 102. What's that? 498 women are not math science. So 102 women are math science. 98 are not. Yeah, so there we go. So there's our table. That's going to be our matrix. So that's going to be our 2x2 matrix. Right? Because it's, it's 2 rows, 2 columns. It's 2x2 matrix there. So now we're going to put that into our calculator. Going down to the steps, it says go to second matrix, get to the matrix menu, move over to the edit, select the size of the matrix, da-da-da-da-da. So let me show those steps now. Here on, I can get this working. There we go. On the calculator. Okay, you see the calculator there? So let me turn it on, clear that away. So I'm going to go through those steps. You'll see it right now. In fact, let me actually let you see. Here's the buttons I'm going to press. All right, here we go. So I'm going to press second. matrix, which is down here, the X to the -1 button. So that gets the matrix. That opens up the matrix menu. And then move over to edit. So I'm going to move over here to edit, push right arrow twice to the edit menu. And then hit enter, it says. I'm going to hit enter. You see over here the buttons I'm pushing. Okay, so there it is. Now it starts off with a 1 by 1. It says select the size, down first and across. So I'm going to go 2, enter, 2, enter, 2 by 2. So then it sets up a 2 by 2 matrix. So I'm going to put in those numbers that we just figured out, which was 38, 160. So I'm going to go 38, enter, 162, enter, and then 102, enter, 498, enter. So there we go. You can see we've got the matrix there, right? That's the matrix put in there. And now it says on the instructions, after you do that, hit second and the mode button right here, the quit, because it's got that matrix stored. Every time I hit enter, when I put one of those numbers in the matrix, it stored it. So it's got it stored. It's got that whole matrix stored. I just quit the matrix mode. Now I hit stat. As I said, I'm just following the steps here. Go over to tests. And I'm going to go way, way down. In fact, the best way is to go up. And then you jump to the bottom of the list and come here to the x squared test. Actually, chi-squared, but whatever. This chi-squared, x-squared test. And hit enter. And it says, oh, you want me to go to the matrix A, where there's the observed values, and it's going to put the stuff in B, and we don't really care about that. We're just going to come on down to calculate and hit enter. And there it is. It gives us a chi-square number and a p-value on this problem. So that's what we want. So now let me go back. Here we are. Sorry about all that confusion there. So anyway, so here's the steps we just went through, right? Test for homogeneity or independence. We just put in the HO, the H1. We went to second matrix, move over to that. I mean, it's right here in the notes. This is the exam 4 notes, right? That I'm looking at here. I hope you all know. This is the exam 4 notes. And there's all, number 8, there's all the steps. Size, mode, stat, test, chi-squared. All right, so we got all that done. Let's go back to the problem now. And so we're going to use our value that we had for x squared. So right in here. So if you look back to the calculator, it told us the test statistic, that's the chi-square or x squared number, which for me was 0.41. It says round to 3 places, 41558. So that rounds to 0.416, right? Because you're supposed to stop here in the 3rd place. This is a 5, so that rounds that up to 6, 416. Then it says it wants the p-value. The p-value calculator gave me was what? 0.519, 51914. And again, it wants me to stop at 4 decimal places. So this is the 4th spot right here. This 4 says leave it alone. So 0.5191. There's the p-value. Now, what does that mean about our conclusion? Well, you're always supposed to compare the p-value to the alpha level. What was the alpha level on this problem? Getting back up here to the top, it said alpha 0.10, right? So the alpha level, 0.10. So what's the story? Well, the p is certainly greater, isn't it? The p is greater. So here we'll say the p is greater than alpha. What does that mean? Well, you know how it goes, right? If the p is low, then the HO must go, meaning go away. But in our case, the p is not low. So the HO must not go away, right? My p-value is greater. It's not low. P is not low. It's greater. So if the p is not low, the HO must not go away, meaning we're going to fail to reject the null. Fail to reject the HO, meaning you're going to keep HO, right? The HO is not going to go away. So I fail to reject it. Don't choose that except one, even though I know we say we're keeping though. It's fail to reject the null. So then what does that mean? Well, we're keeping the HO. So let's go back up here to the HOH1. So that means this is the one we're going to keep. And remember, evidence is always what in that case? Weak, right? Evidence is always weak evidence for HO. It's always strong evidence whenever you go with H1, but we're not going with H1 in this case. I'm going to cross out H1 and I'm keeping HO. Meaning, so what does that mean? That means the evidence is weak and we're weakly concluding HO was what we assumed to be true, and evidence was weak. So we stick with the original assumption that gender and math science major are independent. So we're saying, yeah, it looks like gender and math science major are really separate. They're independent of each other. They're not connected. And you might say, well, yeah, it made a difference, right? Because for the men, 19% of them were math science majors, and for the women, 17%. So that's different. Yeah, but it wasn't different enough. It was pretty close. 19%, 70%. That just could have been a lucky sample. I know we surveyed 200 men and 600 women, but it was so close, 19%, 70%. That just could have been a lucky couple of extra men that happened to by luck get in the sample. And really they're the same, and it doesn't really make a difference your gender, man or woman, as far as how likely you are to be a math science major. That's our conclusion, because evidence was weak because they weren't very different. Remember, in a hypothesis, you're always assuming HO is true. So we're assuming HO is true. From the beginning, we assumed it was true. And only if evidence was strong would we go with H1. Well, evidence was weak, meaning they came out pretty close. That p-value was high. That 0.5191, that's 51% or close to 52% chance that it could have just been luck. Remember, p-value is the probability of luck. That's a pretty high chance that it could have just been a lucky sample. It's just luck. They're really the same. The fact that 17% is a little lower than 19%. That was just there's a 51% chance. That's just by luck. And so the evidence is too weak. So we're just sticking with the idea that gender and the math science major are independent. They're separate. They don't affect each other. Evidence wasn't strong enough. So down here, what's our conclusion? There is what? Is it sufficient? No. Evidence is weak. It's insufficient. It's one of these. It's not this one. It's one of the insufficient ones, right? So it's insufficient. Evidence is weak. Let me cross that out with the same color. So it's one of these insufficient. Evidence was weak, right? So weak evidence. So evidence was insufficient, not enough, to conclude that college major and gender are dependent. And this one says that college major, what does this other one say here? To conclude that the distribution of college majors is not the same. Okay, now you might say, wait a minute, is that sounds weird. So is it the dependent one? Is that right? You come up here and you go, well, let's see, what did we conclude? We concluded, no, we crossed out dependent over here. We crossed it out, right? That was H1. We're going with HO, which says independent, right? So what's going on here? This can trick a lot of people. So let me help you with this. So evidence is weak, right? Evidence is weak, and they are independent. We conclude they're separate. They're separate. They're independent. Your major, your gender, they just have nothing to do with each other. We concluded, right? They're independent. So should we circle this dependent one? Yeah. We should actually. Why? Because look what it says, that there was not enough evidence to conclude, right, that they were dependent. That's right. There was, right, whenever they say insufficient, that's like saying not. There was not enough. It was insufficient. There was not enough. It was weak. It was not enough evidence. Well, I shouldn't say not weak. It was weak. It was weak. So there was not, this is really saying, to put in other words, that there was not enough evidence to conclude, not enough evidence to conclude that they were dependent. That's true. There was not enough evidence to conclude dependent. That's why we ended up going with independent. We believe they were independent because evidence was weak, right? There's insufficient evidence, not enough evidence to conclude that college major and gender are dependent, right? There was not enough to conclude dependent. That's why we went with dependent. Evidence was weak. Oops, it's a bad circling here. Evidence was weak, and we went with independent. So that's right. I know that can be confusing. And so there we go. There's our conclusion.